What if time isn't a straight line but something more flexible, something that under the right conditions could fold, twist, or even repeat? Scientists have explored this idea through Einstein's relativity, quantum mechanics, and theories of closed timelike curves. Some believe time loops are purely fiction, others think they could be hidden in the very fabric of reality. So let's dive deep into the theories, paradoxes, and real-world experiments that just might prove that time loops aren't just Hollywood magic, they could be real. Time loops. Imagine waking up to the same morning over and over again, every action you take, every word you speak, every choice you make resetting like a broken record. Sounds like science fiction, right? But what if I told you some of the brightest minds in physics have seriously considered the possibility that time itself might not always flow in a straight line? Instead, it could loop, bend, or even fold back on itself, trapping events in an endless cycle. We've all seen movies and shows where characters get stuck in a time loop, repeating the same day, trying to break free, or using their knowledge of past loops to their advantage. But is this just a Hollywood fantasy, or could the fabric of time actually allow for such strange phenomena? Could time loops be real? Could you, in some bizarre twist of physics, find yourself reliving the same moment indefinitely? The idea of time loops isn't just some wild storytelling device. It has roots in deep scientific theories, some of which suggest that under the right conditions, time might not be as linear as we assume. From Einstein's relativity equations to the mind-bending possibilities of quantum mechanics, certain interpretations suggest that time loops might not be entirely impossible. In fact, some theories imply they could already be happening, hidden from our everyday experience. But before we dive into the theories and research, let's break down what a time loop actually is. Is it a glitch in the universe, a natural occurrence, or just a human illusion? Let's find out. Gödel's rotating universe. What if I told you that, mathematically speaking, time travel might already be possible, at least on paper? In 1949, the legendary mathematician Kurt Gödel proposed something that could rewrite everything we think we know about time. He wasn't just any mathematician, this was the same genius behind Gödel's incompleteness theorems, which shook the foundations of mathematics itself. And when he turned his attention to Einstein's general theory of relativity, what he found was nothing short of mind-blowing. Gödel discovered a solution to Einstein's equations that described a rotating universe, a cosmic dance where space and time weren't just linear, but could actually loop back on themselves. In this model, time wasn't a one-way street, it was a circular highway where, theoretically, you could travel along a certain path and end up in your own past. Yes, that means time loops could be a built-in feature of our universe, if Gödel's model were correct. So how does it work? Imagine the entire universe spinning like a giant whirlpool. As space twists, time gets caught in the motion, forming what physicists call closed timelike curves, CTCs. Pathways where an object or person could move through space-time and arrive at an earlier point. This essentially creates a time loop, a scenario where past and future aren't strictly separated. But before you start making plans to visit ancient civilizations, there's a catch. Gödel's universe requires a very specific type of global rotation, one that doesn't match our observations of the real universe. Modern cosmology tells us that while the universe is expanding, there's no clear evidence that it's rotating in the way Gödel's equations describe. So does this mean time loops are impossible? Not necessarily. Gödel's work showed that time itself might be more flexible than we assume, opening the door for other theories that could one day prove that loops in time are more than just science fiction. Closed timelike curves. What if time wasn't a straight path but a loop? What if you could take a walk through space-time and, instead of moving forward into the future, you ended up back in your own past? Sounds crazy, right? But according to some interpretations of Einstein's theory of general relativity, this might not just be possible, it could be a fundamental feature of the universe. Enter closed timelike curves, a theoretical concept that allows time itself to twist and reconnect, forming loops that could trap events in an endless cycle. Imagine drawing a timeline on a piece of paper. Now, instead of keeping it straight, you bend it into a circle so the starting point eventually connects back to itself. That's a CTC, a space-time path where an object, or even a person, could travel and end up exactly where they started, but at an earlier point in time. This isn't just a thought experiment. Solutions to Einstein's field equations actually allow for CTCs under specific conditions. One of the most famous examples is Gödel's rotating universe, which showed that if the universe had a certain type of spin, time loops could naturally form. Other proposals like wormholes and rotating black holes also suggest that if space-time were bent the right way, closed time-like curves might emerge. But here's the big question. If CTCs exist, why don't we see time travelers popping up at random? That's where things get tricky. Some physicists argue that nature might have built-in safeguards to prevent time loops from forming freely. Stephen Hawking's chronology protection conjecture suggests that quantum effects could destroy any time loop before it fully forms, ensuring that paradoxes never occur. Still, the fact that CTCs are mathematically possible raises a profound question. If the universe can allow time loops, does that mean they exist somewhere out there? Or are we just scratching the surface of something far bigger than we can comprehend? Novikov's self-consistency principle. Alright, let's say time travel is possible. You step into a time machine, travel back a few decades, and decide to change history. Maybe you want to stop a major event from happening, or classic time travel trope, you prevent your grandparents from meeting. Boom! You've just created a paradox, a contradiction that could break the very fabric of reality. But what if I told you that some physicists believe time itself wouldn't allow such paradoxes to exist? Enter the Novikov self-consistency principle, the ultimate rule book of time travel. Proposed by Russian physicist Igor Novikov in the 1980s, this principle suggests that if time loops exist, the universe has a built-in mechanism to prevent paradoxes. In other words, no matter what you try to change, history will self-correct so that the timeline remains consistent. It's like the universe is running an autocorrect feature for reality. Whatever you do in the past will always align with events that have already happened. Let's break it down. Imagine you travel back in time to prevent an invention from being created. According to Novikov, something will always interfere. Maybe you accidentally inspire the very invention you were trying to stop. The loop stays intact, and history unfolds exactly as it was meant to. The past is flexible only in ways that keep it logically consistent. This principle has huge implications. It suggests that time travelers aren't free agents. They can't just alter events on a whim. Instead, they become part of history, playing the role they were always destined to play. And here's the kicker. If time loops exist, they must already be playing out around us without causing contradictions. So could time loops be real? If they are, Novikov's principle suggests that we might never even notice. The universe might be a master of self-correction, ensuring that time remains an unbreakable, logical chain. No paradoxes, no rewrites, just one seamless, unchangeable loop. Chronology protection conjecture. Imagine a world where time travel is not only possible but common. People from the future randomly show up in the past, rewriting history, creating paradoxes, and leaving behind a tangled mess of cause and effect. Sounds chaotic, right? Well, according to Stephen Hawking, nature simply wouldn't allow such a disaster to unfold. His answer? The chronology protection conjecture, a theoretical safeguard built into the fabric of the universe to prevent time loops from ever forming. Hawking proposed this idea in 1992, suggesting that while Einstein's general relativity allows for solutions like closed timelike curves, CTCs, which could theoretically permit time travel, something in the laws of physics steps in to prevent them from becoming reality. Essentially, the universe acts like a self-policing system, making sure no one can break causality or rewrite history. But how does it work? One possibility is that the moment a time loop begins to form, quantum effects kick in and destroy it before it becomes stable. Some theories suggest that vacuum fluctuations, tiny, unpredictable quantum changes in spacetime, would build up to an infinite level near a time loop, ripping it apart before it can be used. Others believe that gravity itself could create an instability that prevents time travel from ever happening. So, if Hawking was right, this means that even if we discover a theoretical way to travel back in time, nature will always find a way to shut it down. No paradoxes, no rewriting history, no alternate realities, just one continuous, untouchable timeline. But here's the real question. What if the chronology protection conjecture isn't an absolute law, but just a tendency? Could there still be hidden loopholes, conditions where time loops might briefly exist before collapsing? If so, the universe might not be as rigid as we think, and the dream of traveling through time might not be entirely impossible. Experimental investigations. Alright, we've talked about theories, Gödel's rotating universe, closed timelike curves, and even Hawking's idea that time travel is off limits. But what about real-world experiments? Has anyone actually tried to prove that time loops could exist? The short answer? Yes. And some of the results are surprisingly intriguing. One of the most well-known names in this field is Dr. Ronald Mallet, a physicist who has spent decades working on a theoretical time machine. His idea? Using ring lasers to create a circulating beam of light strong enough to twist space-time itself. If space can be bent, and time is linked to space, then maybe, just maybe, a powerful enough laser could create a closed time-like curve, making time loops possible. While Mallet's work is still in the theoretical stage, it's one of the few serious attempts to explore time loops in the lab. But lasers aren't the only approach. Some physicists have looked at the quantum world for answers. In 2014, a study simulated photon-based time travel using quantum entanglement. Scientists at the University of Queensland managed to create a system where a photon, a particle of light, appeared to interact with a past version of itself, essentially behaving as if it were inside a time loop. While this wasn't real time travel, it hinted that nature might not completely forbid information from moving in strange loop-like ways. Then there's the research on black holes and wormholes. Some theories suggest that rotating black holes like Kerr black holes could naturally create conditions for time loops to exist. The challenge? We can't exactly step into a black hole and check. However, astronomers are constantly studying the effects of black holes on space-time, looking for signs that time behaves differently near their event horizons. So, what's the verdict? We don't have a working time loop yet, but experimental research is pushing the boundaries of what we know about time. Could future discoveries reveal that time loops are not only possible but already happening around us? Science isn't ruling it out just yet. Time loops in fiction versus reality. We've all seen it in movies. The protagonist wakes up, lives their day, something bizarre happens, and then boom, they're back at the start, trapped in a loop. Whether it's Groundhog Day, Edge of Tomorrow, or Tenet, time loops have become a storytelling goldmine. But here's the big question. How close is Hollywood's version to scientific reality? In fiction, time loops often work as a reset button, forcing characters to relive the same moment until they break the cycle, whether through self-improvement, solving a mystery, or fulfilling some cosmic purpose. But in real physics, time loops, if they exist, wouldn't necessarily follow a narrative arc. Instead of a magical force trapping someone until they learn their lesson, time loops in nature would be an inherent feature of space-time, a direct consequence of Einstein's equations, quantum mechanics, or even higher dimensional physics. So, could someone actually get stuck in a loop like in the movies? If closed timelike curves (CTCs) exist, it's theoretically possible that information or even conscious beings could experience cyclical time, constantly returning to the same point. But here's the catch. Novikov's self-consistency principle suggests that any action taken in a time loop must be consistent with history, meaning you wouldn't have free will to break out of it. And then there's Hawking's chronology protection conjecture, which suggests time loops should be physically impossible, nature's way of keeping history untouchable. That means no respawning, no rewinding, and no magical resets. So, while fiction lets us fantasize about infinite do-overs, reality is a bit more stubborn. Time loops may not follow Hollywood rules, but who knows? The universe still has plenty of secrets left to uncover. Maybe one day, science will reveal that fiction wasn't too far off after all. So, could time loops really exist? Or are they just a wild sci-fi fantasy? While science hasn't confirmed them yet, theories suggest they might be possible under extreme conditions. Maybe the universe is hiding its biggest secrets in the folds of time itself. What do you think? Are time loops real, or just a mathematical illusion? Let me know in the comments. And if you love exploring the mysteries of time and space, don't forget to subscribe to InnoVision Tech.